Welcome to this video on PLC selection guide. In this session, we will learn how to choose right PLC for our automation project step by step. Now, let's begin. So, first one, we have to understand the application requirements. So, before selecting the PLC, first we have to understand the application thoroughly. So, we have first, in this section, first we have to understand the total number of inputs and output. So in the inputs and outputs, both digital input, digital output, analog output, we have to consider. Next one, identify the types of signal. So like 24 volt, 230 volt, 4 to 20 milliamp sensors. So we have to consider these voltage requirements. Next one, we have to understand the process type. So whether it is a continuous process, whether it is a batch process, or whether it is a discrete process. So this process type we have to understand. The next one is speed requirement. So we have to know whether we need to use any high speed input or any special function or high speed output. The next one, future expansion. So we have to consider 20 to 30% spare of total considered inputs and outputs for the upgradation or for future expansion. The next one, we have to choose PLC family. So here we can select the right PLC family. So based on the application. So for small machine, we can select micro PLC like Siemens logo, Allen Bradley Micro 800 PLC. We can select for the small machines. For medium machines, we can go for modular PLC like S7 1200 or Omron CP1H. For the complex and large project, high-end PLC such as S7 1500 or Control Logic's PLC, we can select for the high-end PLC application. Also here, we have to understand the scan time for the micro PLC, modular PLC and high-end PLC. Here we can also consider how many PID blocks are there, how much how many control modules we have to program, how many equipment modules we have to program. So based on the scan time program memory, we can select the micro PLC, modular PLC and high-end PLC. The next one, select the IO module. Now in this step, so we have to select the IO modules according to our signal type. So digital inputs and outputs depends on the voltage and current. So analog module should match the sensor such as RTD 4 to 20 milliamps transmitter and 0 to 10 volt sensors. So if we require any special modules like high speed counter or any communication card, Modbus card, so we can consider that as well in this step. Now next one is communication and integration. Decide how our PLC will connect the other PLC or other devices. HMI and SCADA usually use Ethernet or Profinet or Ethernet IP protocol. Here we have to also consider VFDs and servos. They may use Modbus or Profibus communication protocol. So for smart sensor, there is IO link we can use for the communication or for integration. So now next is software and support. So we have to always consider the software and support. We have to check the software licenses which fits for our budget. So ensure local support, trainings, these both thing it should be available. Also we have to consider PLC is compatible for the HMI, SCADA system, operating system. So all these thing we have to consider in the software and support. Now here what we will do, we will consider one example, pressure control system. So here for pressure control system we require 6 digital inputs, 5 digital outputs, 1 analog input and 1 analog output. It also need one PID control and Modbus communication for third party devices from the let's say for weighing transmitter or for let's say for third party PLC communication. So based on the application, here good choice will be Siemens S7 1200 CPU 1214C and one 4 analog input and 2 analog output card with the communication module. Now what we will do, we will go to the TI portal software and we will configure this hardware configuration, and let us see how we can configure in the TI portal. So here we can start TI portal. Here we can select create a new project. We click on create. So simply we'll go to the project view. Here we can add our required device. So here we can select controllers, HMIs, PC system and other drives. So from the controller we have selected S7 1200 and from the 1200 series we have selected 1214C CPU. So here we can select the required CPU. So here based on the program memory and scan time, here we can select the number of CPUs. Here S7 1500 we can select, S7 300 and S7 400 are old series from the Siemens. So here we will select 1214C DC DC DC. So here we can see the required work memory. So from the 1200 series itself there are 2-3 CPUs. So in that there are different work memory. So here work memory is 75 KB. Here we have selected work memory 150 KB. So let's add that CPU. So here we have added the CPU. It will take some time. So these are some security setting. If we require that, we can keep it. Allows secure PGPC and HMI communication. If we require, we can keep it, or simply we will disable it. So here we have added CPU. Now it's time to add analog input and analog output module as per our requirement. So here maximum we can add 7 number of digital inputs, sorry, 8 number of digital inputs, analog output and digital output cards. So here what we will do, so there is one card. In that card 4 analog input and 2 analog outputs are coming. So from that we will add this card. So if we go to the properties of that card, we can select the type of signal. So here for the 4 channel analog input, we can select the measurement type, whether it is current or voltage, whether it is 0 to 10 milliampere, 4 to 20 milliampere under current, and under voltage it is plus or minus 2.5 volt, 5 volt, or 0 to 10 volt we can select. Here also we can select the required address for this particular card. Also for analog output we can select the type of signal, whether we want voltage or current. Also what we will do, we will add one communication card. So we require Modbus card, that is RS485 card. So from the point to point communication we can select this particular card, and on the left side we have to add that card. And if we go to the properties, we can select the required configuration. We can do the required configuration. So here PLC configuration is ready. So now what we have to do, we have to add one HMI. So in the same way we can select the HMI, whether we want 4 inch, 7 inch, 9 inch, 12 inch, 15 inch, or we require basic panel. So in the basic panel, visual scripting we cannot do. The high-end application like scripting or high-end recipe we cannot do in the basic panel, but in the comfort panel we can do that. So based on our application we can select 7-inch KTP 700 PN module. For the DP module there is only Profibus communication, and for the PN module we can do the Ethernet communication as well. So always prefer Ethernet communication, so that it is very easy to communicate with the other PLC, third party HMI. So here we can add the HMI. So required setting we can keep it like as it is, and simply we can click on finish. So while adding HMI we can add the communication details, or here we can select. So now it is communicated. If the PLC and HMI both are same, so this communication is very easy. So simply we have to drag this from this point to this HMI communication point. So it will make the communication link automatically. So no need to do separately. So this is one good thing for the Siemens. So now whole our PLC and HMI configuration is ready. So now we can start doing programming. Let's come back to the our previous slide. So here, so now our configuration is ready as per our example. So here we have to always consider one size higher than our design requirement. So always we have to prefer Ethernet CPUs for easy communication. Always we have to use some standard and reliable brands like Siemens, Rockwell, Schneider, Omron, Mitsubishi. And also we have to consider our power supply and environmental condition. So that's all about the PLC section. So if you like this video, please like, share and subscribe this channel. Thank you.